All right.
I'm hungry.
I'm good. I have a cheese sandwich, and you can have half of it. Do you want it?
Maybe it's good. I got to have the whole thing.
Oh, don't worry. Don't worry. A half one. It's got so much cheese and butter in it.
Oh, no, I'm good.
Oh. It is gonna upset your stomach.
No, it's not. I'm eating it right now.
Your stomach's always upset.
No, my stomach was upset before I did.
He was like, Chris, do you want a sandwich? So I ate it, and I was like, oh, my stomach feels just good.
Y'all just gonna complain about everything. I'm not bringing y'all any breakfast anymore.
Oh, I appreciate it. Don't get me wrong now.
No, that's all right. You
But I
done
got to
done
have
it
me some
now.
macaroni and fried chicken and biscuit and gravy.
All right.
It was really good. I just think it was by the time I got done eating it and I had grease in my hands everywhere. That could have been better.
I didn't expect for it to do that. I bought a new cookie sheet, and I think the cookie sheet kind of did that. I don't know. It's a new cookie sheet. All right. What? What? Y'all laughing at me? I went to Bilo and bought all kind of new cookie sheets
It's
stuff.
okay, it's the cookie sheet's fault.
Huh? The butter went through the I guess I put too much butter.
Do you cook them in the oven?
Yeah,
I think
grill
I
it.
just
Do a
could
grilled
quit.
cheese.
That's what I was thinking.
What?
Do a grilled cheese. Don't put it in the oven.
No, that is a grilled cheese. I thought you said cheese toast. I just thought you said cheese toast.
It's called cheese toast. In the South, it's called cheese
It's
toast.
broiled. No, there's a difference.
Grilled cheese is
Cheese
too.
toast is broiled. Isn't it? Like garlic cheese.
I put it 500 degrees, and then I.
Yeah, that's what I was thinking.
Or griddle.
Yeah, you
What
grill it,
the-
toast it or bake it.
You can't
Put
flip
it
it
on the
across.
wall. You need to stand on the table.
No, somebody. No, I don't need to be on the table. Somebody will say I'm dancing on the tables in class.
Wait till we get to the Mexican restaurant.
Yeah, I will be dancing on the
Dance on the
table.
bar.
I'll dance on the table and. Hold on, let's see if I can bring this down. Bring it down. You know what? I am just amazing. Look at there. I am amazing. There we go. And I'm about to fall down. No, I haven't had anything this morning. Okay, so fifth root, 243, and the fifth root of what? Break it up. X to the 15, and the fifth root of x to the what? The first. Now, what's the fifth root? Bleh. What's the fifth root of 243?
3.
3. What's the fifth root of x to the 15?
3.
And this stays in your pocket. Because if you got a pocket full of dimes and the machine only takes quarters, what are you left with? Pocket full of dimes.
Okay, I think I'm understanding it now.
Good.
Getting there.
Then we'll move on to something more discouraging.
Okay.
One more. How about one more?
Yes.
Now let's do the one that Mrs. Ugg sent.
Oh, I figured it out. Can I send you a different one?
You can do what?
I said I figured that one out.
So you don't want the class to benefit from it? You just screw the class or what?
I mean, if you guys want to benefit from
10.3, 15.3, let's look at it and see if they want to do it.
Hold up.
You want to do that one?
No,
Huh?
how did you get the fifth root of 243 again?
Okay, hold on. That's what y'all said. It should be on the spreadsheet. Let's go look.
I don't have Excel, so on the spreadsheet.
Well, I'm going to pull it up for you.
Please.
The fifth root, or what root are we talking about? The fifth root?
Fifth root
Yes.
of 243.
There's the fifth root right there. I guess I'm wrong. Okay, I thought it was, I've got something wrong. Hold on a minute.
But how do we,
Just hold on a minute. I've got something messed up. I don't think we should have class today. I think we should just go into the Mexican restaurant.
we should be like,
It's a Monday.
reroute?
Well, I gotta work this afternoon, so I can't mess with y'all.
I told you, we are not inviting you.
Let me tell you something.
Let me tell you something. Let me tell you something.
I'll come and sit the table over.
Let me tell you something. Y'all just bear with me. There. Okay, now, this should be, I know what it's doing. When I copied it this way,
Yeah, you're supposed to copy it diagonal.
I thought I did. C to the third raised to the fourth power. C to the fourth raised to the fourth power. That's right. 243 should be in the third. There is a 243, I thought.
There is. It's three, yeah, it's three to the fifth, it's 243.
Not by mine.
Oh, excuse me.
Okay. 1 to the fifth. Oh. Hold on. 3 to the third power is not 729. Oh, I read the wrong. Oh, I know what I did. That's equal to B to the, that's A to the third. A to the third. Now, copy that. How about that? Sorry. And this is A to the third. Somehow, I think it took, I knew those numbers were too big. There. How's that? Much better. Well, I'm glad y'all finally decided to say something 45 minutes into class.
You know what?
What? You
I
gonna
hate to
quit?
believe them, but no, I gotta go and take my test.
What test?
For the next
You're not supposed to take tests during class time.
For the last one?
That's the whole purpose for doing it online. Just go, just leave. Hurt my feelings.
You know what, y'all treat me like a stepchild, that's all.
Yep, that's what we're trying to get you to quit.
That's all right. When I hit these millions,
Quit school.
we'll know something.
It's easier to quit school than it is to try hard. You got that, Miss Wilson?
No, I didn't hear that.
Yeah, it is. It's real easy to quit.
Yeah, whatever.
Bye, Miss Wilson.
Bon voyage.
Sayonara.
Uh-huh.
She's a good student. Don't tell her I said that. All right, how we doing? Is that looking a whole lot better? Miss Jones, looking better?
Sure.
Miss Jones is like, still don't know if we're in the right room or not. She had this look on her face like, what are we doing in here? About the numbers, I bet they get big on the 10, don't they? Oh, they start to get big. There we go. And that's 8 to the third. These are easy. The 10s are easy. Why? Because we base 10 system. All right, so there's your numbers. Sorry. And 243 is right. I thought 240, or is it 343? Okay, I don't see 243, or is it 343? Which one was it?
243.
I don't see a 243. There it is. Okay, I'm sorry. we'll save this. Oops, sorry. Save as help losers out.
Please help losers out.
Are you gonna do a mass email or
I'll do it to everybody.
no? Thank you.
Yes.
Yeah, thank you so much.
Yeah, thank you, and leave. Okay.
I'll be right back.
No, that's okay, I understand. All right, now that we got that out of the way, how about this one?
But how do you put the 243, the fifth root, 243 in the code? Well, I know there's
That's
like
two forty-three to the what?
and you put the uproot to the thing, to the 5.
The uproot to the thing to the 5. Okay, how am I supposed to translate that?
Okay.
How about
So
243?
triangle,
It's called caret symbol, and 1/5.
So why do you have to do 1/5?
The 9th root of 5t to the 3rd times the 9th root of 3t. Did you get it? It should come out to be 3.
Yeah, because when I did 5, it said 8.
That's going to be a big number.
It's gonna be the 9th root
Number 7.
Well, the 9th root
over
of what's 5 times 3?
15t to the 4th.
And that's it. Well, Hubert, why aren't you breaking anything down? The 9th root of 15? 9 won't even go into 15, much less the 9th root. So you've got a machine that takes dollar bills, and you got pennies in your pocket. You ain't gonna get no coat because you got pennies in your pocket. You ain't gonna get no coat because you need to have a dollar bill. Unless you got 100 pennies in your pocket, you're not gonna get a coat. This is a dollar bill. This is pennies. You're not going to be able to take the 9th root of either one of these.
Want to do another one?
Mm-hmm.
I have another one that I sent you to.
I'm trying to get there, people. I'm trying. All right. I'm looking. Okay, there's that one you sent. This is 10.3.31/7. 10.3.31/7. All right, do that one.
Can you make that bigger, please?
Yes, Diva. I'm sorry.
I
Yes.
gotta go get glasses. I can't see anymore.
I am messing with you.
Thank you.
Break it up. What is the domineering number?
2.
2. So you have to think in terms of perfect squares. Okay. Now, before we even start the problem, we need to bring it down to things in the square root. So, 80. 80. Let's go from the beginning. Square root 2. Okay, 2 squared is 4. We can do that. Let's break it up into 4 and 20. Well, guess what? Oops. 20 has a 4 in it, doesn't it? Yes, Hubert. So we can break that up into square root of 4, square root of 4, square root of what? 5. So we've just broken, I'm sorry, I'm just writing all over the place. There. Okay, now let's do the same thing with the 7. Well, 7 isn't divisible by 2, but what is?
6. 6.
Mm-hmm. Okay, what did I just do? Well, I took my $5 bill to the front desk and I just got it changed into quarters. Why? Because this said you need quarters. And I just changed everything I had into quarters. Well, you had some nickels in there too, Hubert. Well, I can't use the nickels, so they just stay in my pocket. So, what is the square root of 4 and 4? Square root of 16, which is 4. Or the square root of 4 is 2, square root of 4 is 2, 2 times 2 is 4. What's the square root of a to the 6th? A. Yeah. A to the 3rd. So that's done, and that's done. And what's left in your pocket? 5A. Piece of cake. Now, some of y'all are going, this stuff is hard for me. It is, because you are learning to think in terms of twos, in squares, of cubes, of fourths, of fifths, cubes, fifth root, da. You're not used to doing that. You're used to just thinking in terms of what? Square roots. All right, let's try nerd.
Try number 13.
Say again?
Try number 13.
Well, let me go over this one. I don't know. Just send it to me if you can.
I did.
Okay. Let me go get out of this one. Pull up. Okay. That's number 9, and this is number 10. You hadn't sent me number 13.
I didn't send you number 13.
Huh?
I didn't send you number 13.
You sent me 10. There's 10 right there. I'm going to go over it after number 9. That way I do this homework. This is 10.3, 39, 9, and then I'll go over the next one, which will be 41, 10. All right, try that one.
I can't send it to you because I can't connect to the network.
Okay, I'll copy it there, just as long as I can see it on the monitor. Take a minute and break it up if you need to. Oh man, I think I need to get me one of those little hair bows. Hair up. All right, so what are you gonna break this one up into?
281.
That's what I would do. 2 and 81. Now, what about the negative? Is it okay?
No.
Why?
Would you not do 3 and 54?
Well, 3 and 54 is not, well, it all depends on the cubes.
Because it's a cube root.
I'm sorry.
It's in the 3
I'm
and
sorry. 81 is a perfect square. So you're 54, 3 and 54,
Because then you
yeah.
down here, you got 3 and 18.
And your perfect squares, your perfect cubes are right here. There's your perfect cube. So what you want to do is find a perfect cube that will go into 162. 54, did you say 3 times 54? 54, 2 times 27. So that's probably where you might want to go.
Well, because then you can break 54 down into 3 and 18.
2 times 27. Perfect cubes. Look at your perfect cubes. Right there. So, you look at the cube, and the cube tells you, okay, you got to think in terms of perfect cubes. So, let's go with the cube root. The cube root of -1, and I'm just going to put the cube root of -1 because I'm just pulling that negative out. And the cube root of 3 times what? 54? Well, that don't help us very much, but the 54 does because, as you saw, 27 will go into 54. So I'm going to break this up into the cube root of, and I'm just going to put it all under 1. -1 times 3 times 2 times 27. And I'm going to keep going. And what can I break that? Well, that x to the 9th, do I need to break it up? No, because 9 is divisible by 3, so you don't have to break it up. So now you just do it. Okay. So, what can you take the cube root of? 27 and the x to the 9. So you can use those quarters. So you can use those. And I'll give you 3 what? X to the 3rd, Hubert. 9 divided by 3 is what? 3. And what's left in your pocket? The cube root of what? -6. If you look at the index and you think in terms of the index, you shouldn't go wrong. Now you could have done, did you say 81? And 3 times 27, I believe, is 81, right?
I
You
didn't
could've
see
done
that cube, I didn't see the cube root
Uh-huh.
on that, when I started the problem, that's why I said 2 and 81, because I was thinking it was just.
But you could have done 81.
Could've.
3 times 27, somebody check.
It's 81.
You still would have got the same thing.
Okay.
Now, if you hadn't paid attention to the cube and said that the 81 was 9, then you didn't pay attention. So, if you catch yourself doing that, you need to get in the habit. It's called a highlighter. Take the highlighter out on each of these problems and you put a highlight on that index because it will get you on a test.
Well, that answer, I put it in, it said it's not correct.
Well, I don't know what the answer is, but unless they did something I don't know about, hold on.
Negative 3x.
They just brought the negative out front. It's the same answer. They put the negative out front here, and that's fine. Not a big deal. I would take this answer or this answer. Okay? All right, let's see what else we got. Where'd my questions go? They just disappeared. All right, y'all send me another one. Was that it? Miss Rose, you had another one?
What's the one that I sent you at 3:05 p.m. yesterday?
Right here?
Yes.
10-349/13. You're right.
That's, okay, that's the one.
Okay, but there was another one up here, 10, I think you sent. Didn't you?
There's one right below it that you already did.
Okay, I thought I did. Okay. All right. I thought there was, okay, this is number 13.
Yes, please.
All right. I'll blow it up. That's a test question. I'll tell you that right now.
You can delete that.
Delete what?
What I typed out. Yeah.
How can we make fun of you if we delete it? You take the fun out of making fun of you.
I'm from the class.
I guess you don't want us to talk about you when you leave either, do you?
That's fine. Could be the highlight of y'all's day.
We're getting one too much.
There you go. So now that you showed us a different way to do it, I can get like halfway through it and then I get stuck.
I'm good. I'm doing pretty good.
I think.
Well, 7, what does 7 go into? Does it go into 17?
It will twice.
It goes into 14. So you
Yes.
break 17 up to the x to the 14th, x to the third.
Third, yes.
And then you do the same thing with 14. Well, you don't have to do it with 14.
It's just gonna be y squared.
And z to the 22nd, I'll break it up into what?
21
There you go.
and 1.
21 and 1.
So
And then you
use
just
that-
find out what you can use and what you leave in your pocket.
How, that's where I get that.
So, the 7th root of x to the 14th times x to the 3rd, y to the 14th, z to the 21st, and z to the 1st.
Would it not be y to the second?
Why wouldn't you do y squared?
I hadn't taken the 7th root yet. I'm just breaking everything up.
Okay.
All right. What's the 7th root of x to the 14th power?
X
Squared.
What's the 7th root of y to the 14th power?
Y squared.
What's the 7th root of z to the 21st power? And what's left in the pocket?
to the third z.
That's good. What did I tell you all a while ago? If the exponent is what? Then the index.
Over?
No, if the exponent is less than the index, you can quit. just remember, if you can't take the square root, or in this case, the seventh root of something, that's like nickels. If the machine only takes quarters, you can put your quarters in there, but your nickels are what? They're useless. So you put them in your pocket. Question? Now, we went over how to multiply, and I told you that multiplying is like multiplying fractions. It's real what? Simple. What about adding? Well, we're going to go over that now. How do you add radicals? Well, just remember, you add radicals just like you add dang old variables. And write that down. And is this 10.4? Adding, somebody look in the book and see if it's adding 10.4, adding and subtracting.
10.4 is dividing.
Okay, well this is 10.5. I'm not going over dividing right now. So 10.5, what is 10.5?
Expressions containing several radical terms.
Not adding or subtracting?
No. 10.6
Well.
is solving radical equations.
Well, we're going to go over adding and subtracting because y'all haven't went over that yet. I don't know what section it is. Y'all just have to find it. So let me erase this section because
I'll say on none of these say adding, it just says simple or dividing.
does it say combine?
Nope.
Okay, well, I'm going to show you how to do it. All right, so in pre-algebra, you learned that 2x plus 4x is equal to what? 6x. You also learned that 11x minus 2x is what?
9x.
9x. You also learned that y plus 2y is equal to 3y. So you learned to add the coefficients or combine the coefficients. Oops, sorry. And do what with the x's? What did we do with the variables on all of these examples? You just carried them, right? So you add or combine the coefficients and carry the what?
Variable.
The variable. Carry the variable. Because the variable in these examples is basically what I tell students in algebra is a what? Label. Boxes of cereals. Boxes of cereal is a label. 3 boxes of cereal plus 4 boxes of cereal is 7 boxes of cereal. Does the label change when you add or subtract? No. 7 cans of OIL minus 4 cans of OIL is equal to 3 cans of OIL. The label does not change. So, what do you have to do when you're adding and subtracting radicals? You have to get a common radical. I'll let you finish writing that. Let me find this section because I can find it hard to believe that you don't have this in your book. I think they just disguise it as something else. I don't know whose fault that is.
Is that 10.4? 10.4?
I don't know. I'm fixing to go look. And I thought I was going to look here, but evidently I'm not. And I can go here because it'll quit doing its thing. It's just spinning, right? Just spinning.
in adding and subtracting radicals, you need to find a common what?
Radical. Oh, we couldn't get in it while we did it, could we? There, now it's working. All right, 102. Chapter 10. Huh. This is it. 10.5. Yeah, adding right here. Adding and subtracting. Okay, now. Gotta have, just like we had before, you gotta have common what?
Variable.
Terms, common terms. So somebody tell me what this is.
Sun stars.
I don't have a problem with that. How about what's that equal to?
1 bucket of water? I
Two
mean, 2.
buckets of water.
It's gonna be 10 square root of 2.
Piece of cake.
I like the draw better.
Now, are they always going to be in similar terms? No. And that's where the previous section kind of pays off. Let me give you an example. What? You need to. You
I'll
don't.
draw it on.
Yeah, hold on. Let me pull that back up for you. There you go.
Okay.
All right. Sometimes they're not going to be the same. So you just quit. All right, let's try something simple. 3 square root of 8 minus 5 square root of 2. 3 square root of 8 minus 5 square root of 2. 3 square root of 8 minus what?
5 square root of 2.
Now, if you see one like this on a test, don't say, well, you told us you got to have a like term, so you can't do it. No. You get a like term. First of all, the square root of 8 can be what? Broken down. And what's the square root of 4?
2.
And what's 2 times 3? Oh my gosh, look at there. What do we have? like what? Terms. And what's 6 minus 5?
1.
1 square root 2, or just what?
Square root
Square root 2. Just remember that 1 is right there.
So in this case, there's not an understood 2 in front of the,
Yes, it's right here. On the radicals up there in the little, it's a superscript. That's what you do when you don't have like terms. And chances are you're going to start seeing it because you know your perfect squares. Let's try nerd. I always liked doing these. When I was in algebra, I actually got a kick out of these because I could understand them. That's one of the few things I understood. All right, let's try this one right here. 4 square root of 3 plus 2. I'll just blow it up for you and then we'll do it. Now, what does it look like? Multiplication. So, what do you do if you have 2 binomials and you need to multiply? FOI. FOIL.
someone's are arguing. Someone's are arguing.
4 square root of 3 plus 2. 4. I gotta write it first. Square root of 3 plus 2. And what's the other one?
Square root of 3 minus 5 square root of 2.
Minus 5 square root of what?
2.
I'll bring it down after I finish writing. All right, so there's your problem. So use your FOIL method. And I'm going to write everything out because you're just learning how to do this. So you should be writing it out too, unless you're one of those special students that can do it between the blue notebook paper lines. So 4 square root of 3 times 1 square root of 3. That's your first. Outside, or if you're around here, it's outer. 4 times square root of 3 times negative 5 square root of 3, or square root of 2. Inside, or inner, is going to be 2 times square root of 3. And last, it's going to be 2 times negative 5 square root of 2. And we got a 1, 2, well, not going to mess with that. All right, what's 4 times 1? And what's the square root of 9? 3. 4 times negative 5.
-20.
And square root of 3 times square root of 2.
Square root of 6.
2 times square root of 3. And negative 10 square root of what? 2. So your cleaned up version is 12 minus 20 square root of 6 plus 2 square root of 3 minus 10 square root of 2.
Wait, where'd you get the square root of?
Wow.
Where'd you get minus 10 square root of 2? Where'd you get that number
2 times negative 5.
at? Where's the 2 at?
Last. And that should be it.
I thought that was the square root of 2.
If it is, then it's a different problem.
That's the answer?
It should
No,
be.
but original problem, I thought it was 4 square root of 3 plus square root of 2.
Well, what I'm saying is, if I wrote it down wrong, we just did a different problem. Let me see.
I thought the 4th square root of.
It is square root of 2. We'll do it here in a second.
So you don't try to get a radical, the same radical.
Well, you can sometimes. I mean, square root of 8. What's in the square root of 8?
4 and 2.
4 and 2. You notice 4 is a perfect square. All right. Tell me where there's a perfect square in these. There's not. There's nothing. You've got pennies in your pocket. This is a penny. This is a penny. And this is a penny. Why? You can't break it up. All right. Now, add a square root of 2 here, and we'll do that one next. I just did this one because I wrote down the problem wrong. So let me do this. Do this. And Control C, and I'll take it over to the next board. Control C. And next board, Control B. And let's change this, and I'm putting this in red. Change this to the square root. There. Now we got another problem. See how it changes. This is the problem I was supposed to do. I just forgot to write a radical over the 2. big difference here is you get the same thing. 4 at first is 4 squared root of 3 squared root of 3. That still comes out to be what? 12. Outside, negative 20 square root of 6.
Where did you get 12 from?
First times the first.
I know that, but it's still, it should only be like 4 square root of 9.
Keep going.
So then the square root of 9 should be the square root of 3.
No, square root of 9 is 3. 3 times 4 is,
And then just multiply them together.
huh?
And then just multiply them together.
Mm-hmm. All right. Outside, inside. Square root of what?
6.
And last,
Negative 10 times square root.
negative 5 times what? Square root of 4, which is 2. So clean it up. 12 minus 21 square root of 6 minus what? 5 square root of 4 is 2. 5 times 2 is 10. And what's 12 minus 10?
2.
So your final answer is 2 minus 21 square root of 6.
Wait, well, it should
Should
be
be minus
19.
19.
Negative 19 square root of 6.
Because 2 and 3 is square root of positive 6.
Minus 20 minus 1. What's minus 20 minus 1?
Why is it minus 1?
Yeah. Where'd that negative 1 come from?
Yeah, I have a plus.
Inside would be just square root of 6.
I don't know where it came from. You're right. You're right. I don't know. I guess it just came out of nowhere. I don't know.
It's alright.
Negative 19.
Make this feel smarter.
Just negative just came out of nowhere. Negative 19. And that's your answer.
No. The answer should just be negative 19 to the square root of 6. Where did 2 come from?
What's 12 minus 10?
2? What's 2 minus 19?
12 minus 19?
No.
No, I don't know.
3 boxes of cereal minus 2 cans of oil is 2 boxes of cereal.
So you can't,
You and I are on
you
the same
can't,
page.
it's almost like a couple who are being married, you know.
Okay, you can't.
You can't mix oil and, OIL and boxes of
Yeah,
cereal.
that's all, I'm agreeing with you, but they're doing it because they're both those, 19 and the square
The
root of
only
6
two
are
that
married.
go together is these two, oops, and these two. This
The middle one
and
stays by itself.
This is 12 boxes of cereal minus 10 boxes of cereal is equal to 2 boxes of cereal. This is cans of OIL.
Yeah, but couldn't you say those, like how we're.
You
doing-
can, I can put all 3 of them together and get them wrong.
No, I'm saying, like we're doing in factory, when you say the 19 and square root of 6 are married, you know, you can't break those up.
Yeah. No, that's not what I'm saying. This is a different animal than these two. You can't do anything with these 2 numbers and this number. This is just total. This is like, okay, what if I had 2x minus 3y plus 4x? Look here. 2x, look here, plus 4y plus 3x. Would you say 6x?
Yes.
No, you would not.
Yes, you would.
2 plus 4, x and y.
You would say 6x plus 4y.
2
5x
plus 3, last time I checked, was 5.
Oh, well, 5x plus 4y.
Okay, well, why did you try to add the 12 and the 19 here? It's the same type problem.
You're right, we're wrong.
Of course I'm right.
It is, but it's not.
Agree to disagree.
Listen, a man is not entitled to say that very much, okay? Because most of the time, he's not right, okay?
You need to take roll call?
Y'all get out of here. Have a good day.
Agree to disagree.
We'll work on 10.4. I'm sorry, 10.5. I skipped 10.4. So y'all need to work on 10.1 through 10.3 and 10.5.